I'm Etienne Okeke. I'm dialing in from Nigeria, right? Lagos, Nigeria, and I'm a blockchain developer. I do some things around smart contracts. Basically, I'm kind of blockchain integration engineer for the people I work for. I work for Sterling Bank. Sterling Bank is a bank in Nigeria. So Sterling Bank is positioning itself to be a fintech company where we have a lot of financial solutions. So basically, what I do for Sterling Bank around blockchain is asset management, asset tokenization, and collateralization using smart contracts and the blockchain technology, right? So a lot of interfacing with Web3, trying to adapt Web3 to the traditional banking solutions, trying to facilitate loan generations, loan accreditation, understanding credit risk, and whatnot, like everything under it. So today we'll be talking about smart contracts, right? Just give me a moment. Let me share my screen. So I don't know, can you people see my screen? Is it fine? Hi, Joanne, can you see my screen? Okay, cool.
It looks like you're trying to put something on, but it's still we can't see it quite yet, but it looks like you're trying to share something.
Okay, maybe the network or something.
There you go. Yeah, now we can see it. Now we can see it. Perfect.
Okay,
Perfect.
okay, cool, cool. So today we are going to be talking a little bit about blockchain, then we talk more about smart contracts, right? So the content for today, like I said, we talk about blockchains, traditional app versus what dApps are. dApps are decentralized applications. That means applications built on top of blockchains, are applications integrated to blockchains, right? Traditional applications and whatnot. Talk about the smart contract and how smart contract comes into play. We have a little understanding of Ethereum blockchain, what it is like, then development on Ethereum blockchain, talk a little bit about best practices, then you can have an open discussion. Probably that should be like 5 minutes, 15 minutes. You can ask questions. Yeah, very crazy questions, right? So the blockchain technology, the easiest definition you can give to somebody about blockchain is that it's an immutable ledger. What do I mean by that? Um, Information you put on the blockchain cannot be erased. A blockchain is like a database, but the difference between this database and other databases are like is an append only, right? You can't delete, you can't update, and you can only append, right? Let me not really say put. Let me use the word append. It's more of like an append. Something has been there already. You just add up to what has been there. So it's not like you put up fresh things from scratch, right? So a definition of blockchain can be said to be an immutable decentralized ledger where records can be replicated on every computer that maintains a consistent state through consensus algorithm, right? I know, I understand. Very big word. Immutable decentralized ledger replicated on every computer with a consistent state and has a consensus algorithm, right? So basically, what is this like? You have computers running, right? Those computers, we can call them nodes. Each of these computers is very individualistic. Each of them is a standalone computer, it doesn't depend on any other computer. So these computers come together and say, okay, we can find ways to arrive at a consensus, and we keep data and that data is replicated among us. right? Let's say there is computer A, B, and C, right? They have same software running inside them, and they say to themselves that, okay, we are going to agree that we will keep informations, or we are going to append information in a particular way, in a particular manner, with a particular standard, right? And since the three of us are keeping this, it's replicated on the three of us, right? Same data, the same information, but um, two factors makes it immutable, right? One of the factor is if I go to one of the computers and try to rewrite what is on one computer, the other two, B and C, is going to say, Mr. A or computer A, you don't have what we have. So we kind of throw you off the ecosystem, or they kind of throw you off the whole network. So computer A becomes like a standalone system, like a standalone computer trying to run its own chain, and it's not in sync with others, right? So the second way that it makes data immutable is that it uses cryptography to hash data, right? So it collects chunks of data. It can take a chunk of data, right? Probably that chunk of data can be 2 kilobyte, 200 kilobyte, can be 2 megabyte, depending on the case, maybe. It depends on the blockchain specification, right? So let's say it takes 2 megabyte chunk of data and it applies this cryptography to it, and it has an output. It takes that output as part of the input of the next chunk of data, right? So it takes another 2 megabyte of data with a hash output of the former data chunk, and produces a new hash, right? So if you come somewhere along the chain and you want to change data, the hash is going to change. If the hash changes, that means the next block hash is definitely going to change. Is going to change. So one of the properties of hashing is that what the arbitrary data you put into that hash function produces a specific output. Now, if you go to that data and you just add a comma, or you make a letter a capital letter, or you make a capital letter a small letter, it dramatically changes the output of that hash, right? So if you hash data in chains like that, it's impossible to go somewhere along the chain and change data, right? So this is what I mean. A little bit practice of what I mean. So this is a simple blockchain. This is an oversimplified blockchain, right? So, but this is, I think this is going to explain everything we need. So you can see the Genesis block. Where's my cursor? Okay. So you can see from this curly bracket to this bracket, let's call that the block, right? And this block has an index number of 0. It has a timestamp when it was printed, and it has some data, right? Bitcoin refers to this data as the Coinbase, right? So it says initial block of the chain, initial block in the chain. So preceding hash, there is no hash previously, and all these data being hashed together produces this output, right? So if you go to the next block, you see that this is an index number of 1. It has another timestamp of 6 days difference. Let's say it produces a block every 6 days, but that's not ideal, right? There's a transaction inside. There's a sender and there's a recipient and there's a quantity. Let's say this is 50 Bitcoin, or probably 50 Ethereum, or whatever it is. Right. So there's a preceding hash. You can see this preceding hash is a hash from the previous block, right? And this is a new hash. So the same thing happens again for the third block, and there's also a preceding hash, which is 436, and you can see 436 here, and there's a new hash for this block. Now, if I come in between this chain and I come to this second block and I change this 50 to 51, or 50.10, it changes this output hash, right? It changes. It's no longer going to be 436F, la 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 la. So it's going to be a new, completely new number. If that comes as a new number, then here is going to have a new number. That also means that this hash output for this block is going to change because the data input into this block, which includes the previous hash, has changed, right? So that makes it a little bit difficult to hack. I don't want to go into the details of how the computers have to go through proof of work or through proof of stake to understand themselves and the security measures that come with proof of work and proof of stake. I think that can be a webinar on its own, right? So
Yeah, we did do that already when we reviewed the white paper, the Bitcoin white paper. So
okay, great. So like I earlier said, right, I am more of like a blockchain integration engineer. You have your normal web services. There's a database. You can connect to your web server or your API services through your website or through your mobile phone or whatever, Android, iOS, or whatever. But for the blockchain side, the web server now becomes like the database. What I mean is that the web server and the database is both integrated as one, so you can just connect directly to the server from your browser, or you can still actually run it on a server like an API service, and whatever application you have connects to that API service that is directly plugged into the blockchain, right? So that is where I come in. That's what I do. So what's smart contracts, right? um I don't know. Let's say I think Alibaba is the most popular e-commerce shop in China, right? So let's say you go to Alibaba and you order for I don't know what the Chinese people eat. I don't know. The Chinese people eat sushi.
pardon?
The Chinese people eat sushi.
No, that's Japanese. Oh my God, Etienne. No,
Okay, let me say
no,
you
no, no.
ordered for rice, right? You ordered for 1 kg of rice on
Mm-hmm.
Alibaba.
Mm-hmm.
So there's a kind of business logic that comes into play. You have to pay with your card, right? Let's say you pay 10 yuan on Alipay, Ali, one of the Alis now, right? And for a bag of rice, 1 kg of rice, and this 1 kg has to be delivered to your house, right? That's a business logic that happens. But this time around, the business logic is written in mere codes and is just running in the traditional applications, right? But how do we bring in smart contracts into this? Nick Szabo, the person who coined the word smart contract in 1996, he always defines smart contract as a set of promises specified in digital form, including protocols with which every party perform on a premise, right? Previous example I gave about trying to order a kilogram, 1 kilo of rice from Alipay, from Alibaba, right? So you can write it in the smart contract. If I pay you 50 Ethereum, you give me 1 kilo of rice, right? So that is a simple smart contract. You run that smart contract in the blockchain. It is immutable, but we can discuss about smart contracts immutability later. It has a philosophy around it. But let's say it is immutable, right? The smart contract in blockchain is immutable, and whenever anybody around the world sends 50 Ethereum to that smart contract, it gives the person 1 kg of rice, right? So that is a simple business logic, and that's what smart contracts simply do, right? They take care of that business logic and abstract a lot of things for us. So, a couple of characteristics about smart contracts, right? They store rules, right? Give me 50 Ethereum, you a kg, right? That's a simple rule, right? It verifies that rules, right? When you send the 50 Ethereum to the smart contract, it verifies that you actually sent that and all those things. Yeah, you are the person that has to send it. You're sending it to the right contract, and because it has verified that and it proves to be right, then it's going to execute that rule, right? it's many a times smart contracts execute, they are self-driven, right? They execute autonomously. So that has given rise to other very amazing applications of smart contracts like DAOs, decentralized autonomous organizations. That has also enabled a lot that has to do with tokenizations, ranging from the different types of tokens between fungible and non-fungible tokens, right? So what the smart contract simply does is that it allows that real world constraints to be broken. Right, we go across the blockchain is just like a database. There's no intelligence on top of it. It only knows how to receive data, confirms that data, and receives more data, confirms that data, and receives more data, and confirms that data. But it doesn't really have logics inside it that can more than just housing data, right? A typical example of what I'm saying is what you can see between Bitcoin and Ethereum, right? Bitcoin just has that ability to be a store of value. It just has that ability to be able to hold your cryptocurrency. You have one Bitcoin, but Bitcoin doesn't give you that extra layer, right? Where you can use one Bitcoin somewhere and somebody does the activity, the blockchain learns that the person has done that and he releases the Bitcoin to the other person, right? But platforms like Ethereum enables you to do that. So let's talk a little bit about Ethereum and what Ethereum can do. We talk about transaction fees, what blocks are, and how this smart contract to comes to Ethereum. Okay, so before I get to the next page, transactions in Ethereum are always charged. You have to pay fees, right? You pay fees of certain amount, and there's an EIP that is going to be released next month. I believe that should be 9th of August. I can remember EIP 1559. It's an amazing concept. It has amazing philosophy around burning of fees, because fees in Ethereum is by the auction method, right? If you can bid higher fee, you have a transaction. You want to store a piece of data on the blockchain, and you have to pay to store that data. And several other people want to store their own data on the blockchain, and there's a miner wants to collect a certain amount of charge from you people to store you people's data. At a point, the queue becomes very long. I mean, the pool of people who wants to store data become very large. Then the miner says to himself, okay, I think I can make more money if I tell you guys that I can charge a little bit more for accepting your transactions into the pool. And when he does that, people from that pool will start saying, okay, I'm no more paying you 1 yarn, I'm now paying you 1.5. Somebody says, no, I want
Uh-oh.
I'm paying 1.7.
Okay, we couldn't hear you for a second. Yeah, we couldn't hear you
Hello?
for a second. We can hear you now.
Okay, okay, sorry. Now somebody says, no, I'm not paying 1.7 yarn again because my transaction is more important to me. I want to pay 4 yarn. So there's a spike there, right? So the person's transaction definitely gets included into the block. So what I'm saying is that there's an auction method. There's a pool of people who want to send that data to the blockchain, and these people have to bid for space in the blockchain by paying fees. And what if some amount of these fees that are being bidded are burned? That is what the IP 1559 comes with. So that means at a particular point, Ethereum becomes deflationary because what is being burned is more than what is being mined, or block rewards that are being returned. It's a different webinar. So I've talked a little bit about blocks, about wallets. Smart contracts have their own accounts, right? And ordinary users on the smart contract on the Ethereum blockchain have their own accounts. It's not so for all blockchains. For example, if you work with a typical blockchain like Waves blockchain, right? An account is an account. Yeah, it's left for the user to know whether he wants to transform an account to a smart contract account, or he wants to just leave the account as an ordinary account. So the EOA stands for like external owned account, right? Account owned by everybody that can be used by anybody. Then the CA means a contract account. But we talk about smart contracts, it seems as if we forget about the compiler, right? We forget about the visual machine that runs the smart contract. That's the Ethereum visual machine that compiles that smart contract. So this is what it looks like on a very high end. You have the developer. This
Ooh, we lost you again. Okay,
like
you're back.
okay, yeah. Sorry about that. You have the developer by this end. You have the tools he using coding, whatever integrated environment he's using. That might be Remix, that might be VS Code, and many a times these integrated environments usually have uh, test and deployment plugins or assets integrated into them. So these environments also connect directly to the blockchain, can be Ganache, can be Get, some of these tools, because they also have testing capabilities, right? They allow you to, they run their own local blockchain, a kind of test network blockchain, right? So these blockchains can be divided in a particular way. You have the private blockchains or the private networks, and you have the public networks. Public networks, you can also call them mainnets, right? Um, why I don't want to call the public blockchain or the public networks just mainnet is because we also have other test nets like the Robson, the Rinkiby, the Kovan, and the GER. Right? These are test nets that are also public. Right? The same way you are going to call the mainnet, that's almost the same way you can call each of these. Now, this is the idea. I started by telling you people about a computer that is a node that runs a blockchain, right? So your local host, your local machine, your laptop can also be a node, right? Running a blockchain. So in that instance, whatever tool you are using, whatever um, integrate it, whatever IDE you are using, right? It's directly connected to your laptop, and you just have to access it through some communication channels, local host, port, whatever port number you are running the blockchain on, right? But if that's not the case, let's say you have a laptop that doesn't have the ability to run a blockchain. What can you do? You can connect to some other third-party services that are running blockchain, right? What you can spin up a blockchain node in Amazon Web Service or whatever web server you are using, right? Um, whatever cloud provider or web service you are using, you can spin up a node there. Then you create some kind of APIs or some kind of access point, and you access that. You access the blockchain running in that instance. If you don't want to use that instance, there's some third-party applications that are already running blockchains that you can just get the APIs and probably get the API keys and communicate to the Ethereum network using that blockchain. So, like I earlier said, it's divided into two. You have the mainnet and the test net. The test net is where you do all the testing where you can. The mainnet is where you go for production. Right? The testnet can be a public blockchain. It can also be a private blockchain that you just run on your local host, right? Uh, uh, when you run a blockchain on your local host, you can either connect the blockchain. You can just be the only participant in the blockchain. That makes it a testnet. you can connect that private blockchain to other blockchain, to other pairs, right? That can make it a private network or a consortium where it's for enterprise solutions, right? Um, you can connect the blockchain you're running on your local host to some other test blockchains. Right? You can. There's always a configuration files that can allow you play around with all this, right? So whenever you do that, you develop your code, you deploy it, and then you can invoke your smart contracts and have it do what you need it to do at several points and several times. Right. So let's talk a little bit about market considerations and let's go off code and off technology a little bit. Right. So usually when you want to launch a blockchain product, there are three things you have to consider, right? You have to consider the market needs. Is it really necessary to launch this product with the blockchain? It's quite true that the blockchain is quite revolutionary and it brings a lot of benefits. It also brings a lot of demerits and it has its pros and cons, right? When you're applying blockchain to this application, what is it like? For example, let's say the Central Bank of China, right? The People's Bank of China does transactions and settling transactions across China, 1.7 billion people. I think the central bank needs a computer that can make probably 100,000 confirmations per second. Right? A lot of people are buying and selling, and considering the fact that China is also heavily inclined to digital money, right? E-money, e-yuan, and stuff like that. So, but if you bring up a blockchain, can you have a blockchain that can do 100,000 confirmations per second? That brings the issue of scalability, right? Many of blockchains we have now are not quite scalable, so they have a lot of amazing technology and insight, but they're not quite scalable. So, how is it going to operate? It's is it something that you need it to be fast? Is it something that you want to be operating on the go? Do you want everybody to be able to connect to the blockchain, or just some specific people to connect to the blockchain, right? And last not the least, this is one of the very interesting topic and also a very hot topic in the blockchain space today, which is regulation, right? What's the regulation around it? Is Are banks are allowed to run blockchains? If they're allowed to run blockchains, what kind of blockchains are they allowed to run? Can they build their own blockchains and within them the bank to run blockchains? What about e-commerce companies? Are they allowed? Because probably e-commerce companies might be listed as on stock markets. Their shares are securities. Are they allowed to list their shares on the blockchain? Does the regulation allow that? Does the Security Exchange Commission of different jurisdictions allow that to happen? How is it going to interface with other countries and economies and financial systems? Right? So this is also a question we keep asking ourselves in our company, and we try to see how we are going to stay in tune with our own central bank and don't be sanctioned. Right? So it has been very exciting for me because I came from the traditional web development background. Then I started working on public blockchain. Then now I have to work with private blockchains where a lot of institutions around Nigeria have to connect to this infrastructure to see how they can harness that benefit, right? So with the examples I've given, right, this has a lot of use cases in payments, in data integrity, uh, data integrity, decentralized identity. It's also a very hot topic now, right? The central banks are trying to see how they can merge decentralized identities together with um, payment systems, right? Trying to do the thing around CBDC, like central bank digital currency and whatnot. So asset management is basically what I do for a living. Every morning I wake, that's what I do. Then record management, yeah, cuts across everything. So when I say fast payment, I know I gave an example earlier where let's say the central bank needs to build a system that confirms transactions. Let's say 100,000 transactions per second. That's crazy, right? How are we going to handle that if it's to come on the blockchain? But the real fact is that if I swipe my debit card, right, the money leaves my account. But in the real sense, it is not being settled between my bank and the merchant. Right? It settles probably after 24 hours, after 48 hours. It doesn't settle in real time. Right? But it's not so with blockchains and cryptocurrency. Blockchains, they settle in real time. Right? If I send you Ethereum, the Ethereum enters into your wallet, immediately is being confirmed on chain. And that happens almost immediately, right? Let's say in the next 10 minutes, in the next 5 minutes. So that's what I mean when I say it's a faster payment system. Right? But the Visa card, the MasterCard, and the different forms of cards that we use, for example, don't settle in immediately. Let's say you transfer from one bank to another bank, they still don't settle immediately. So thank you. I would say let's talk about questions now, but that we might want to have a look at what Solidity actually is. So
Yes. Let's do
let's
it.
see what
Let's
I
do it.
can
This is
write.
the fun part. This is the fun part.
Okay, yeah,
Come on,
I've been speaking a
Etienne.
lot.
Come on, come on.
Yeah, I've been speaking a lot of English. I don't think developers like English, right? So I guess you can still see my screen, right?
Yeah. Yeah.
Okay, so once you go to remix.ethereum.org, you're going to be this on my name.
Remix.ethereum.org.
Yeah,
Remix.ethereum.org.
dot
Okay.
org.
Okay.
So you're going to
In
have
case anybody wants to do
a
it with you.
okay, cool. You're gonna have this, right? This can be a little bit overwhelming, a lot of things. You have contracts here, you have scripts, you have tests, and you can export some of these files, or you can import. You have your documentations here, and let's try to create a new file. Let's say sample.sol. So .sol is extension for Solidity, right? And I have a new script here. So another name you can call smart contracts. You can refer to them as persistent scripts, right? These are scripts that you write and you deploy to the smart contract and it stays there. So Solidity always starts with you declaring the version of your compiler. You can say pragma Solidity let's say 0.50. And, uh, this is how you start with Pragma Solidity. You state your version. So you can do something a little bit dynamic, right? You can say, I want this to compile between certain mode of compilers, right? You can say it should be between 0.50 to let's see 0.0. 8.0. So, um, sorry, I can't remember this for now. It's not clear in my head. Let's keep that. Okay, so you can also state between compilers you want to use, different form of compilers you want to use. So simple contract, let's say contract. What name can we call it? Probably should we build a token? I don't know. Let's say let's say what name are we going to name this token we want to build now?
Let's call it Shanghai blockchain.
Shanghai is a little bit long. Let me just say SA blockchain.
Yeah, perfect.
Okay, so you have your curly brackets. Inside your curly brackets, you can start writing whatever you want to write.
Mm.
So we can say there's going to be a balance, right? Somebody should be able to check his balance. Somebody should be able to transfer tokens from one person to another. What does an ERC20 do again? So this is an ERC20 token, right?
Mm-hmm.
Let's make it. Let's actually do a better ERC20 token. Let's say we go and look for ERC20 token documentation. I don't know whether you know what's an ERC20 token. So ERC, right, means it's like an improvement proposal, a kind of standard which uh, look at what happens. Let's say there are two exchanges. You have Binance and you have Hotbit, right? These are two distinct exchanges. I want to create a token that can be easily integrated to Binance, and it can also be easily integrated to Hotbit, right? And I also um, and we also want to make it in a sense that Mr. Mike, Mr. James, and several other persons can be able to create their tokens, and it's easily integrated um, among several exchanges. Right. So there's a standard which enables people to do that. That is the ERC20 token. If you are creating a fungible token, that is basically you're transferring from one person to another. Um, you can use an ERC20. Right? So let's say ERC20 token standard. So there is an actual documentation for that. You go to eips.ethereum.org. So this is something you can read later. Let me see what I can share with you guys from the chat. So this is the standard for it. So from this standard, you can see a couple of things. It has a name, it has a symbol, it has some decimal places, it has a total supply, a balance of an account, you can transfer, and you can transfer from. So transfer from means that you can enable somebody to transfer from your account. Is that risky? So
Mm.
you have um, you have 1,000 yuan ERC tokens in your account, but you can enable somebody to transfer from your account. So by enabling somebody to transfer from your account, you have to use the approve function to do that, and then you can always check allowances. Is the person allowed to do this or do that? How much did I allow a spender to spend from my account, right? Then the spender has to call this function saying that I'm transferring from this account to this new account, and this is the value at which I'm transferring, and this has to do with checking if you are allowed to do that. So here you have a transfer event. So what happens is that there's an event that is being emitted, right? You can do your own standard, or you can just use something here. And there's also an approval event. I want to allow somebody to transfer money on my behalf. And once I do that, there is an output being sent. So I might have to copy codes at some point so we can be faster. I hope you guys won't mind me
No, it's
copying.
okay.
Yeah. So Solidity is it's you can also go to
Maybe we can maybe we can check in with Max and 4NF to see if they have any questions. Do you mind? Because
okay, okay,
we've gone
okay,
over a
that's
lot. Max, just to ask, Max, do you have a question or 4NF? You guys are still here. Let me see if they put something in the chat. There's some unread messages. No, Etienne. No, no, no. Let me see. I guess not. Max is. I guess you're okay. Okay, go ahead. If they have a question, they'll chime in when they're ready. But it's fine. Go ahead. I was looking in the chat. Can you explain the difference? There we go. There's a question. 4NF.
mhm.
There you go. Can you explain the difference between pure and view? That's
Yeah.
regarding functions. That's the first question.
I don't have the differences off my head, but they're almost similar, right?
Mm.
Beyond being similar, view is usually used when you want to read from the blockchain, right? You clearly want to read from the blockchain, you can just use view. But sometimes you want to read from the blockchain and you also want to upgrade some things. You also want to add some data to the blockchain. There you use pure. Yeah, sometimes it can also allow you not to use any of them, especially also when you okay. There are two things you do to the blockchain, right? You can either write to the blockchain or you read from the blockchain. So many a times when you read from the blockchain, you use view,
Okay.
right?
Does that help? 4NF? Does that answer your question? Then okay, then there's one from Max. Can you suggest Solidity courses? Max says. It's a good one,
Okay,
Max.
a very good Solidity course. You can go to consensus. Not this consensus. Let me look for consensus. This is Academy. They have some courses, some amazing certification courses there.
Yeah,
Uh,
Consensus is one of the more popular ones. There's also that blockchain, the Blockchain Institute, I think it's called.
Blockchain Council.
Yeah, there's a few of them. And
Yeah,
then there's like Coursera. It
yeah. The
depends
couple
on
of them,
yeah.
couple
Consensus,
of them
but
are.
Consensus is one of the better ones, but it's a bit pricey. So it also depends on your budget. But they're sort of like top notch because Consensus is related to Ethereum. So they're probably the best, right? To go to.
Yeah. So it's just like learning programming languages, right? Once you get used to one of the programming languages, you can always port your knowledge to other languages, right? So it's also same thing with most blockchains, not all, but most blockchains. If you master Ethereum, you can always port your experience in Ethereum to Bitcoin or to anywhere, right? So I work on a couple of them. But for if you want to go through the route of Ethereum, I will strongly suggest consensus, right? Because they take care of a lot of things, and you also have some extra courses that you can take for free around auditing smart contracts, understanding more about Web3 and integrations. You can see other courses around some of the private blockchain solutions like Hyperledger Bezu. You can also see courses around Quorum, blockchain. Yeah.
I just
I,
put some there. DAP University,
yeah,
Etherblocks.
that University is also great. Etherblocks is also very great. So the difference
Yeah.
between these you
I'm
can
gonna
follow
put
it.
them. I'm gonna put
Yeah.
them one by one so you can. Okay, because that didn't work. So I've got. Sorry, you can go ahead and I'll just put them in
Okay.
one by one.
Yeah. So the thing about Ether blocks, why I like Ether blocks is that he quotes most time he quotes on live, and he quotes live. Then he kind of gives you the complete overview of what he's doing and why he's doing what he's doing. Right?
It's 3 o'clock.
Sorry, you don't mind my time. So it kind of gives you a kind of one-to-one feeling with what he's doing. That university is also good. I learned a lot from him back then.
Yeah, his
He,
stuff is good. He's very. Oh my God, he's very American, very
yeah,
enthusiastic. It's like
yeah,
okay, you can't get bored with him.
yeah.
There's a Solidity playlist. There's the Udemy tutorial by
Mhm.
Sebastian is quite good. I've got I don't know if you've used Edureka on
If I
YouTube. They're quite good.
no, I
Yeah.
don't
Yeah.
know
There's also
Sebastian.
Udacity,
Okay.
Coursera. I've got I've got loads. I've got a list. Coursera is quite good. Um, and then there's the Blockchain Institute. There's the Blockchain Foundation, but these I think are a little pricey. These I think are a little pricey. And that's about it that I can think of off the top of my head. Yeah.
Yeah, I think this is more than enough. I hope it's not overloading.
Well, you know, hey,
So,
why not? Give people options. I personally, I like DAP University. I like
yeah.
Eat the,
Mhm.
and I check in with Udemy from time to time. The ones that I paid the most for are Consensus. I took the Intro to Blockchain certification with Consensus. I did a free boot camp with them. So
Mhm.
they're quite good, but they're a little bit more pricier. So it also depends on how much you want to pay. At least YouTube's free. But I'm new to coding, so I'm
Yeah.
literally starting from baby steps.
Mhm.
But you guys that are more advanced, you might be able to move at a faster pace and get a lot of it by yourself. So it really depends on
Yeah.
your learning style
Okay,
too.
cool.
Yeah.
Yeah. Another question. So,
Uh, yes.
right?
Mm.
If you are approaching some institutions, right, they might require you to have certifications around blockchain, right? But from my experience, I think what's more important is what you have built. Can you point to projects that you have built?
Like
I think
developing a
that
portfolio and showing what you've
yeah,
done. That matters
yeah,
more, I think.
yeah,
Yeah.
that matters more than any certification you can get. You get a certification is fine, but hardly will you find somebody that says, "Okay, give me certification on this." Rather, um, you can find that around. Let's say you're working for some government institutions. Those guys can be very official and very formal, right? But working for startups, working for average organizations, probably organizations that are worth $1 million, $2 million, even $10 million. I don't think they will require you to have a certification. So that's it
The
for now.
blockchain council offers a lot of certifications. I don't know if you've heard of them. The blockchain council, they offer
Yeah,
loads and loads of certifications. But like you said, I mean, ultimately, you got to be building stuff. It's good to do hackathons, ensure that
yeah.
you've built some stuff and build a portfolio too. That helps.
So also, if you are if you are not more like a developer, right? You are not like a coding type. I can also advise you to do the blockchain thing because it also serves like a proof to have the blockchain certificate. Right? But if you are a developer, you code and all those things, blockchain developer, blockchain engineer, you can just go through the route of building projects. Can you volunteer for projects? You have your normal job, eight to five job, yeah, but can you do some part-time projects for some other companies or for some startups? You work for them for 6 months, and you learn a lot from them. It Having that in your portfolio, right? Especially if the startup goes live, I don't know, the project goes live. It's huge. It's huge when you tell somebody that go to Uniswap. I have a token that is on Uniswap, and I was part of the people that developed the system and the token. It's huge. Yeah.
We lost you. Are you back?
Hello?
Yeah, now you're
Yeah.
back. We didn't hear. I didn't hear the last thing you said. You got cut out a bit.
Oh, okay. I said,
Uniswap.
yeah, I said it's huge when you have to tell somebody that go to Uniswap, there's this token on Uniswap, and I'm part of the team that developed the project behind this token. Right? It
Mm,
gives a lot of credibility than any certification you can have. Yeah.
yeah.
So
Cool. Are
I,
there any other questions, guys? That was a lot. Thanks, Etienne. You
yeah.
answered. Anything else? I hope that helped Max. And Max says he's using Edemy, Ethereum, and Solidity, the complete developer's guide. Okay, that's good. I just play around with things until I find what works. At least when I have the time. Yeah.
Oh, for
Okay.
you, for yourself,
Hmm?
like, you mean you play around with things and
Like I go to the different learning portals, and like sometimes I learn simultaneously, like I the same thing on different like um platforms, just to see how they teach it differently, and I stick with the one that helps me to absorb that particular thing. Like I don't know, I'm a crazy learner. I don't follow a linear way of learning. Like I don't stick with one, and I jump around because they all teach in different ways. So anyway, yeah, Etienne, all right, do you
yeah.
have some more for us, or is this the end?
Um, I guess this is the end because the people on I don't know. I think this is the end.
Yeah, we had a lot. We had like 40 people sign up, but as usual, only a few. They clock in and then they leave because other things come up or whatever. But
Yeah,
this was quite good.
yeah.
This was helpful.
Probably if we are going to have a new section, right, another section around Solidity, then we can probably do some live coding, we can develop a token, launch it, do a simple front end, a simple wallet front end integration, and connect to our token on the blockchain and see how we can transfer money
That
from
would be
it.
brilliant. Yeah, that would be brilliant. But I know you're busy, so you just let us know when you're ready, and then we'll set it up. No worries. But yeah, that'd be awesome if whenever you have time.
How do you do this? You run this monthly, weekly?
Yeah, I do them monthly. So like there will be one next month. Try to just do one a month because people are busy. But yeah, so if you wanted, I've got one scheduled for August already. If you wanted to do in September or October, whenever, just let me know and I'll put it together.
Cool. That's fine. That's fine.
Yeah,
Okay.
brilliant. Well, thank you so much.
You're
All right,
welcome.
guys.
Pleasure.
Alrighty. So I think that's it. Thank you guys for coming. I've recorded it, so I'll put it on I'll send it out in email and put it on the YouTube channel for all the other folks that weren't able to show up. Okay, brilliant. All right, Etienne. Thank
Okay.
you.
Okay. Bye.
Bye. Bye.